All right, so we are now going to go ahead and get started. So, hello everybody. Thank you guys all so much for being able to make demo night this session of summer 2025. This is an excellent opportunity where all of our students are going to be able to show off their projects, show off the incredible work that they've done over the last 3 weeks. Working on projects like this, of this high intensity in only a 3 week period, is an incredible accomplishment just in of itself for what they need to be able to take charge with. So I really do want to say congratulate all the students. Thank you guys so much for being able to make it. And think of tonight as a victory lap. You guys are showing off everything that you have done across the last 3 weeks. Students, please keep in mind the order that I sent in our class chat earlier today so that you know the order that presentations are going to be going in, but I'll also be calling you guys out. I also want to politely ask for all stakeholders and other people in the room. We're going to be saving questions for the end of every student's presentation. They're going to have about a 3 to 4 minute talk, and then we have about 2 minutes for questions from anybody. So feel free to ask at that point, and please ask our students anything about their project, anything about their Blue Stamp experience, or anything about what they want to do now that they are full Blue Stamp engineering alumni. So those are the type of things we want to let you guys go ahead and ask. So we'll be getting in with our first speaker now, who's going to be one of my PM students. We're going to be having Anya speak to you guys. So Anya was an absolutely incredible student these last 3 weeks. She worked on what we would consider one of our fundamental projects to getting introduced to engineering. It is a self-driving car project where there is an Arduino that interfaces with some actuators, some given motors, and then interfaces with a variety of different sensors or input elements and uses those in a variety of ways to navigate around a given environment. And while the project started very fundamental, Anya chose to completely accelerate the project into a very modern context using some modern techniques that self-driving cars use with a combination of computer vision, image processing, or AI identification. So I'm going to go ahead, I'm going to pass it on to Anya. Please go ahead and take the floor.
Thank you so much, Everest, for that introduction. So, hi everyone, I'm Anya, and I'm a rising sophomore at Edgemont High School. So, as Everest mentioned, I decided to make the self-driving car project. So, here is my car right over here. So, it works using these two motors right here, these two yellow motors, and they're connected to the motor driver right over here in the back. And this motor driver is connected over to the Arduino board, which is right here in the center. And this Arduino board is really important because that's how I send code and tell the car what to do. So I write the code on my computer, and then I upload it onto this Arduino board to tell the car to move forwards or left or right, accelerate, anything I want it to do. It's through my computer and this Arduino board. And then there's also a couple extra modules, as Everest was mentioning, such as this ultrasonic module right over here in the front. So this ultrasonic module is used for long distance obstacle avoidance. So what it does is it sends out ultrasonic waves from one of these circles, and then the other circle, using a couple of equations written in code, it sees how long it takes for that wave to come back to the module based on how long it takes for the wave to bounce off an object in front of it. And so it's really effective to see how far away an object is from the car, and then using certain code, I can tell the car to back up or turn away from the object so it doesn't crash into it, which is a really great feature of a self-driving car, so it doesn't run into certain objects. So I wanted to show a quick demo of how this works. So this is my car. It's going to start moving. And as you can see, there's a wall in front of it. So the ultrasonic module detects that, and then the code tells the car to back up and turn so it doesn't run into the object. So for my modification, I decided to add on image detection capabilities, which I thought was super cool. So what I ended up doing was I had to switch onto a Raspberry Pi board, which is right over here, and it's actually connected to my Arduino. So I send signals from the Raspberry Pi over to the Arduino on the car to tell the car to do certain things, like go forward or turn, anything like that. And it views images using this PiCam, which is attached to the Raspberry Pi. And so I'm using this PiCam along with an algorithm called YOLO, which is an AI algorithm for the image detection. The main thing that I wanted my car to be able to do was when this YOLO algorithm detects a person using the PiCam, it would see where the center of the person is located inside an image frame, and then it would send certain signals to the Arduino board on the car to tell the car to move left, right, or forwards in order to follow the person. So I'm going to show a quick demo of how YOLO works. So this is my setup. And this is me. It's detecting me as a person. There's a teddy bear in the background, a couple books. And obviously that's not a remote in my hand, that's my phone. So it can be wrong a couple times, but it's usually pretty accurate. So I decided to use the person functionality in order to have my car follow a person. And so I definitely ran into many challenges while doing this project, and it took a really long time to debug some of these errors. So, for example, many times the car just kept moving backwards, no matter what the code was telling it to do, no matter where the person was actually in the frame. So now in the future, since these are ongoing errors, I need to see what voltage values are coming out of the Raspberry Pi and what they're exactly triggering the Arduino pins on the Arduino board to do, and if they're doing that correctly. And I'm going to be using a digital multimeter to see what exactly is going on behind the scenes and why I can't figure out why the car is doing certain things when I need it to go in other ways in order to follow the person effectively. Through these errors, I definitely learned a lot about patience and working to find new solutions for these errors, always trying to innovate and see what I can do. So I've actually never used a Raspberry Pi board before. This was completely new for me, but it was such a great experience because I was able to see how it worked and challenge myself to see how I can test it out. So I ended up choosing to make this self-driving car project because self-driving cars are so prevalent in our world today, and I thought it would be so cool if I could find a piece of that and work on it and see how it functions on my own in such a mini version, which is just super cool for me to be able to see how it works. Bluestamp gave me such a great opportunity to build, code, debug, and make an amazing project start to finish independently and so hands-on, which was a great experience. And I'm so grateful I was able to work on this opportunity. Thank you so much. Does anyone have any questions for me?
Floor is now open to the audience. Any questions from
Sure.
anybody?
Hi, Anya. I was wondering how you're connecting the Raspberry Pi to the Arduino. What are you using to communicate over? Is it a certain protocol or something?
So, my instructor actually gave me two options. Either I could connect wirelessly, so that I wouldn't have to deal with any wires of connecting the Raspberry Pi to the Arduino and it could just not have to do all this wiring, but that would have taken a really long time. So what I ended up doing, if you can see over here, this Raspberry Pi has three wires connecting from pins 11, 13, and 15, and those pins connect to pins 3, 4, 5 on my Arduino board. And so if a certain signal on my Raspberry Pi is set to high, based on some code telling it if the person is on the left side, then a certain pin should be high, then the Arduino board says, like, if a certain pin is high, then I should turn left for the car.
All right, thank you for your question. Any other questions from the audience? All right. Well, may I please ask for everyone to please give a huge round of applause for Anya. That was a super, super awesome presentation. Thank you so, so much. Our next scheduled speaker for today is actually unfortunately not able to join us. They have fallen ill, so I want to shout out Jennifer, who was an excellent student of mine, worked very diligently on a three-joint robotic arm project, but she's going to be unable to present for us for tonight. So the next speaker actually is going to be Christopher. So Christopher is actually coming to us fresh off of school right now, able to join us right after his school lets out. And Christopher was another really amazing individual to have in class. He has also done a self-driving car project, but he has chosen to use an avenue of modifying a number of the input sensor devices to have the car have different functionalities. And he also added additional output devices. So now not necessarily actuators, but using sound as another form of identification of what the car is able to see and being able to drive it remotely. So I'm going to go ahead and hand it over to Christopher. Christopher, please remember to unmute yourself and please show us what it was that you put together.
Okay, so uh, hi, my name is Christopher, and I'm going into the 10th grade at South Pasadena High School. The project I chose was a self-driving car, same as Anya, which can either be controlled using a remote control or drive on its own while using obstacle avoidance modules on the front of the car to avoid walls and obstacles in its way. Anya already did a great explanation of how the motors and sensors work, so I don't know if I'm going to need to do a re-explanation of that, but I'll just get into my modification, I guess. So the main modification I added to my car was a color sensor. I don't know if you can see it right here. It's able to detect the color of the floor, ideally as the car is driving, and it'll play a certain tone depending on what color detects. Unfortunately, due to my school starting yesterday and running into some technical issues, I'll only be able to show the color sensor right now instead of the full moving and detecting demo. Um, so yeah, but so we'll plug it in right here.
Mhm.
Oh, can I flip my camera?
Should be able to. Yep.
So right here, I'll also show what the serial monitor is detecting. So right now it is detecting black and it's making this not very happy noise. But let's say we put something blue under it right here. Uh, hopefully it'll detect. Yep. So blue, let's say blue, and it's making this happier noise.
Yep.
Let's go
Definitely
with
higher pitch.
something. Yeah, let's go with something green right here. Um, okay, green. Oh shoot. I'm sorry. Okay, might have to move on from green because it's not. We'll go to white. So it's making a higher pitch noise. Okay. All right.
Mhm.
Well, it's detecting white. So yeah, so now I'll explain my code. So the code I used here. Actually, I'll just explain the code and then I'll show it after. The code I used cycles through red, green, and blue filters on the PCS 3200 sensor, which measures the frequency output for each of those, for each color, and maps those frequencies to 0 to 255 RGB values. These RGB values represent the intensity of each color channel, which the program compares to preset ranges to identify the detected color, and then it'll play a corresponding sound. While I had a lot of fun learning how to do this, it did come with some difficulty, as it took me a while to understand what the sensor output actually meant, since I had to convert its pulse frequencies for each color into RGB values, while also dealing with lighting and distance affecting my readings. I felt that even though it wasn't easy, I was still able to learn a lot with BlueStamp and learn a lot about things that I didn't even think I'd be interested in, such as breadboards, which is this where all the wires go into, and microcontrollers like the Arduino, which is how the car moves and all that. Overall, I'm very glad I chose this project, as when I was choosing my project for BlueStamp, I was just looking for something that would keep me engaged throughout the 3 weeks. And since I had played with remote control cars a lot as a kid, learning more about the mechanics of how robotic vehicles move felt like a good fit. Now, at the end of the program, I'm able to say that it was truly a good fit, and I was so happy I was able to share my project today at Demo Night.
All right. Thank you so, so much. Do we have any questions from the audience? All right. Well, Christopher, I do want to ask. So you did mention that you sort of ran out of time a little bit just due to other things showing up, in your life. I did want to ask. So what is your end goal functionality for the car once everything is working?
I think this weekend I'm gonna try to, because I was having trouble calibrating the speed and setting up my like demo so that the car was able to move straight onto each color. So I think this weekend I'm gonna try to be able to program it so that it's able to move straight and uh go on each color while also being able to do the color detection.
Mhm. Got you. Nice. I'm excited to see that. Please feel free to share that with us even after the program ends a little bit. I'll be checking the Discord, maybe over the weekend. So show me when you get that working. Are there any other questions from anybody? Alrighty then. Alrighty then. If there are no other questions from the audience, we're going to be moving on to our next speaker. So, our next speaker is actually going to be one of our international students who has joined us. So, we are an online remote program. We came out during the, pandemic sort of time where we had to do things remotely. And one of the upsides of keeping this program going is that we are able to offer it in this sort of unusual way. That includes us being able to offer it for international students who want to call in and be able to join us. I know Minren, I know for you right now it's fresh and early in the morning, so I'm glad you're able to make it. And Minren definitely utilizes opportunities super effectively. He was able to acquire parts that he needed to use to do his project. He was able to go from doing a three-joint robotic arm project and has since expanded it to basically include the fusion of multiple projects put together. So it became very, very involved. And as there are always a couple kinks or tweaks that need to happen with a program that involved, he has still put together something really, really impressive. So Minren, please go ahead and show everybody about it.
Hi everyone, I'm Minren. I'm in Warfare School and I'm ninth grade, 15 years old. And this is my main project is a robotic arm. We can use the controller here to move the arm and move the catching. So here's it's moved by like it's have four servos, one here to control the catching, and one is two is here to control the arm, and another one is going to control the turning. And I also add something like I want to do more, and I do this a little card. Actually, at first I think I want to let this robot arm to move, and I don't want to like using a controller still connecting to it. So I want to use the Bluetooth module. But actually, I didn't finish that yet because I'm not very good at coding, and the coding for is a little hard for me. So I think I will done it this weekend. And this is what I've done now. It's a little messy, but you can still see I do a lot on it. And also the biggest problem I met is on this car because I'm in China. They cannot mail me the part I need, so I need to buy them online myself. I try my best to choose the nearest place to buy them, but still use 3 or 4 days. So I actually need to be really quick. It's very stressful. And another thing is this Bluetooth because I've never having any class for coding or learn coding on myself. So the coding for the Bluetooth is very hard for me. Actually, at first I choose this robotic arm project is because I think the coding will not be really very hard. But then I feel like yeah, I think if I done this robotic arm, I can also done more, and I wanna like challenge myself. So I choose to use the Bluetooth. Even yeah, I think that's very good and very it's challenging me. Yeah, and I joined Blue Stamp because I think this will improve my coding skill actually because I'm not very good at it. And also, I love building. Like choosing this robotic arm, another reason is I think there will be a lot of building on this. So that's what made me very happy and interested in that. And also, I think Blue Stamp gave me many helps and made me improve my coding skills. Like I felt a great improve here. So I think that's really good. Thank you. Are there any questions?
All right, thank you. Any questions from the audience? And we got any questions about either the arm or the car portion or the struggle that Bluetooth tends to offer? Well, Minren, I do have a question for you. So I know you've had to take a bit of a pause on like the building element in order to get the wireless communication up and running. What is your plan for how to attach the arm to the car so that's able to drive around?
Oh yeah, sure. I'm gonna use the Bluetooth connecting the controller and another place is the arm or the car, whatever we want. Like using the Bluetooth controller, I can connect them without these messy
Mm.
things. So, and if I want to move them, I don't need to like chasing it to control that.
Mhm.
And what's more, on the Bluetooth coding, I still didn't done that, so I'm not very sure what can I s- talk about that.
All right. Well,
I,
no problem. I
I
think you're going to be able to do it. Definitely keep up with it over the weekend. Are there any other questions from the audience?
I have a question.
Christopher, go ahead.
What are you most proud of about your project?
Actually, I'm proud of my speed. Yeah, I get my things later than others, but I still than every building, but coding is not included because like it's very hard.
Hmm. So, like the rate at which you're able to build the project, you're proud of that?
Yeah.
Got you, got you. All right. Are there any other questions from the audience? All right. What is that a question? Alrighty then. So we're going to go ahead and get on to our next speaker. Minran, thank you so much. Our next speaker actually is another student who has also greatly benefited from the remote nature of the program. So our next speaker is going to be Megan, who is actually one of our students from session 2, which happened 3 weeks ago. So Megan joined us for session 2, working under Josh, who was one of our other instructors from those previous sessions, but she ended up having a conflict week 3. So when there was a conflict that whole week, it's like the demo night is a critical part of the program. We're like, hey, you can come join week 3 of session 3. You can come in, make up that time, and as you can see, Megan's here now. So she's only been my student per se for 1 week, but incredibly diligent. I was lead instructor during session 2, so I still saw the progress she was able to make. She has worked on a very, very cool project, a gesture controlled robot, which is super, super cool to be able to see how it functions. She was able to design a couple parts for herself and print them out for her project as well. So, Megan, thank you so much for making it to demo night. Please go ahead and share your project.
Yep. Hi everyone, my name is Megan and I am currently going to my senior year at Jericho High School. And for my project, I did this gesture controlled robot pause. So as you can see, if I tilt this forward, backward, left, and right, and I do have a demo video that I will show you. So as you can see here, I am standing on the left and the robot car is following the gesture of my hand. It's going forward, backward. And when I turn it, it's turning on a fixed point and not like both wheels are like reversing against each other. And that there's two main components to this project that I learned about. One of them is the accelerometer, which is this part of the gesture controller. I don't know if you could see it. It's like there. Yeah, and basically, in my code, I tell it to, well, the accelerometer reads the tilt for like the XYZ and the X, Y, and Z axes. So in my code, I tell it to read that, and based on the gesture I put my hand at, it reads the tilt and it returns a letter F, B, L, or R. Basically, that stands for forward, backward, left, and right. And then it sends it through the Bluetooth signal to the car. And then the car reads the F, B, L, and R and says, okay, I need to go forward, backward, left, and right based on that signal that it receives. And the other part, which was the more challenging part for me, was the Bluetooth. And the problem with the Bluetooth was mainly the wiring for me. I didn't know that the TX had to connect to the RX pin. So I was connecting TX to TX instead of RX to RX. So an analogy I like to use is basically if I was trying to relay information to you, the TX would be my mouth and the RX would be your ears. So in order for me to relay information to you, it would have to come from my mouth to your ears and not like ears to ears and mouth to mouth, which was the mistake that I made in my wiring. But I'm really glad that I figured that out. And also for my modification, as you saw before, it was this 3D printed case that I made with the cap and handle. And right now I'm also working on like the shell of the car, which is right here. So as you can see, this is the shell of my car that I'm working on. Basically, it's going to go on top of the car and these are where the wheels are going to go. And if you want to see, this is the model for the case for the gesture controller as well. The handle, the box, and the cap. So thank you. Are there any questions?
Open the floor for questions. Questions from anybody, students or stakeholders, anybody who's here.
Oh, when did you learn Fusion 360? Did you learn it during the program or school?
It was actually during a school program. It was an elective called Intro to Engineering and Design that I took in freshman year.
Really cool.
Yep,
Thank you.
super nice. Well, I got a question for you. Now that you have your project up and running, I saw that you have a next step of making the case design for the car. Any ideas for what your next project will be?
I was thinking about like maybe like adding a motion sensor so that doesn't bump into like walls and stuff.
Ooh, nice. A little bit of that obstacle avoidance getting in there. Makes sense. And you're now equipped with all the skills you need to be able to go forth and implement that. All right. Are there any other questions from the audience? Well, if I could call for one final round of applause, Megan, thank you so much for speaking.
Of course.
Our next speaker is going to be one of our PM students. So our next student is going to be Priyanka. So some of the core skills and core talents that we want our students to be able to leave with, I teased a bit at the end of Megan there, is that we want you guys to all be equipped with the skills that after the program ends, you could do this again on your own. You could think of a project idea you have, maybe find a tutorial online, spend 3 weeks just crashing down on it and getting it implemented, and then being able to do that. And Priyanka took that full force in doing her modification. Priyanka did a 3-joint robotic arm project and, similar to Anya, wanted to do a visual identification element with it. So asked me, hey, Mr. Bloomer, is this something I can do? I said, yeah, find something online. We'll send you some parts. Go ahead and do it. And she definitely went forth with that. So I helped out, a little bit, but Priyanka was really able to implement this modification, like something really, really cool out of it. So, Priyanka, I'll let you go ahead and tell everybody about what you implemented.
Okay, thank you. My name is Priyanka, and I'm a rising junior.
Yeah, we have the audio on your phone right now, as opposed to the audio from your computer right now.
Hi, my name is Priyanka, and I'm a rising junior at Staten Island Technical High School. So my project is the 3-joint robotic arm with a camera. So the arm is made up of an acrylic base, and it has 4 servos connected to it. So the first one controls the base, the turntable. The second one controls the main arm motion. The third one controls the smaller arm, and then the fourth one controls the claw. And these are all connected to an Arduino board. And then I also have a Raspberry Pi and Pi camera connected to the arm and for object recognition. And I use an algorithm called YOLO for the object recognition process. So originally, YOLO is pre-trained to recognize certain objects, including like an apple or a person. But I wanted to train the YOLO model to recognize specifically like what I wanted it to recognize. So I decided to train it to recognize 2 different types of candy bars, so a Twix and a Snickers bar. And how it works is the Raspberry Pi is connected to the Arduino with these 2 wires here. And then the Raspberry Pi sends a signal to the Arduino to perform a specific set of movements when it recognizes the object. So right now I'm going to do a quick demo of how the arm works. So as you can see, I have a Snickers bar here, and I'm gonna put the camera above it. And then once the camera detects the Snickers, it turns and then performs that series of events. And then I'm also gonna show a demo of the Twix. Can you see my screen or not yet?
Not yet.
Okay.
Screen share is not going through right now.
I can't see it. Okay. Did it work now?
Yep.
All right. So this is just a quick demo of the Twix bar. So as you can see, it recognizes the Twix and then performs like a similar set of movements. So the main challenge of this project was definitely training the YOLO to recognize the specific objects because it took a very long time. So one of the main problems I ran into was when I was issuing the command to perform the actual training, the Raspberry Pi was not actually capable of completing the full training. So I had to repeat the process on my laptop rather than inside of the Raspberry Pi. And then another challenge I had was when I was creating the code for the Raspberry Pi and the Arduino to send the signals, the original threshold value I had, which would essentially like set the pins on, was too high. So even though the Raspberry Pi was sending the Arduino the signals, nothing was actually happening. So I had to run a few test codes to figure out what the appropriate threshold value was, which eventually ended up working. So I joined Bluestamp because I wanted to gain more hands-on experience and also gain more technical skills, which I definitely have over these past 3 weeks. I've learned more about using the servos, Arduino, the Raspberry Pi, which is also something that I've never worked before. So it was really cool and interesting to be able to use it and learn more about it. And cooler, like, and even cooler, how I could use it to control the actual robotic arm, which was definitely my favorite part of this project. I definitely plan on using all the skills that I've learned at Bluestamp to further develop my project, to like start like maybe like picking up the objects, and also in the future in any other projects that I may plan on working on. So thank you very much.
Any questions from the audience? So that really cool computer vision arm-controlled candy bar sorter devourer. I already said candy bars once. Oh no, I ran out of words to say. But yeah, any questions?
So how did you get all the training data for YOLO? Did you have to label a bunch of images, or did you find them on the internet? Or...
Yeah, so I essentially had to like take all the pictures and then label them. So I took I would say like maybe 20 or 30 pictures. So since it was only two objects, it didn't have to be like a huge number of pictures. And then once I did that, I used a program called Label Studio to label all the images. And then after that, I worked inside of the Raspberry Pi to create and organize all of the folders, and then run the actual training.
Nice. Any other questions? Any other questions from the audience?
I have a question.
Yes, Anya, go ahead.
What is the biggest lesson that you've learned from the project that you would like to tell someone else who's gonna do it again?
I'd probably say the biggest thing was that like sometimes you're just gonna kind of have to do like trial and error. And if something doesn't work the first time, you kind of just have to keep trying again. Like I said, those challenges where the training wasn't completing, that was really frustrating because I was doing it so many times, but it just wasn't working. And then eventually when I managed to figure out that like the Raspberry Pi wasn't capable of doing it, and then when I actually did get it to work by doing it on my laptop, it just felt like very rewarding. And I was definitely very proud of myself for kind of working through it and then eventually getting the recognition work.
All right. Are there any other questions from the audience? All right. Well, one more round of applause for Priyanka. Thank you so much for presenting. Our
Thank
next
you.
student is going to be one of my AM students. So next up is going to be Eli, who I would describe as one of the focused and dedicated students towards his project. Eli chose a very, very software heavy project. And with any sort of software heavy project, there's bound to be errors, not only with like, programming and like syntax errors, but compile errors, software errors, OS errors, library errors, mismatch of data types and library matching. So Eli got the full taste of the software engineering experience, and he was able to turn it into not only one, but two really cool projects. So the first project that he did was an International Space Station tracker that he'll tell you about. But then when it came time to modify, he was like, I'm going to add additional functionality, going to make a fun case to combine everything in, and it has evolved into something really, really awesome. So Eli, you now have the floor. Please go ahead and tell everybody.
Hi, my name's Eli Berman, and I am a sophomore at Paul D. Schreiber High School. I decided to do the International Space Station Tracker project because I'm honestly very interested in space and satellites and that sort of stuff. So here is what I have so far. This is my PyPortal, which is the screen that I use to display my International Space Station tracker. There is a red dot right there that shows where the International Space Station currently is, and it's very hard to see, but there's a yellow curved line behind it that tracks where it's been so far. The reason that there's no case on this is because it's currently 3D printing. Apparently there's a very long process to get it done, so it's taking a bit longer than I expected. The actual case looks like this. I kind of just worked a very long time to get this done. There's an air vent and there's some space to connect it to a wall, but still not here yet. And part of the way through, I came over a little, let's say, a mistake that I had to get over, and I thought that my screen was broken because the colors were inverted and it was split in half, and there were a bunch of other like issues happening. It wasn't loading things correctly. But I figured out it was because I downloaded the wrong software. However, even though I got a new screen, I didn't want it to go to waste. So I decided to put a different project, the weather station, on it. It's a simplified version without buttons, but I was able to do that. And I came across another mistake that I made, which is that I forgot to remove a lot of the code that had functionality for the full weather station version because I have the wrong the wrong wires to connect my buttons to my weather station, which is why I'm not using the buttons. Um, I forgot to code for the fact that the buttons didn't really connect to my screen because I had the wrong connector. So I had to remove that code. It took a pretty long time. Additionally, with the SD card, because my PyPortal is not reading the SD cards correctly, so I had to put everything inside of the actual current working directory, which is the storage that's on the PyPortal. So I joined Bluestamp because I wanted to improve the engineering and coding, and I think that it's helped a lot. Any questions?
Questions are open to the floor. Any questions either about international space stations, weather tracking, anything to do with PyPortal, CircuitPython?
Yeah, I have a question.
All right, go ahead.
Does the weather tracker, uh, is it only your location, or can you set it to like look different cities and around the world?
Well, as I have it right now, without modifying any code, I can't set it to different location. However, the weather station runs on an API, which is basically information accessible to any code. So if you include an API in your code, it gets information, and you have to like actually have it and decode that information and then tab it, which is an issue that I came across when waking around my on my International Space Station tracker to convert the location to coordinates. But it wouldn't be that much effort. You just change like 2 lines of code and you could have it for a different city.
Mm-hmm. Are there any other questions? Well, Eli, I have a question. So you have these two PyPortal screens, but how is it that you combine them into a single project per se?
Um, so the thing that I decided to do is make my custom case double-sided. So a thing that I realized with the first custom case that all that backspace, because it's hollow from one side to the other, it's just a hollow cylinder, or it's some sort of cylinder, but all that space in the back wasn't being used for anything. So I could just cut it in half and then mirror it on both sides, and it wouldn't actually like take away from the functionality of the case. So I decided to do that and make my own custom version of it, and it turned it into a project, basically.
That's so cool. Thinking with ingenuity. Are there any other questions from the audience? All right. Well, may I please ask everybody for one more round of applause for Eli? Thank you so much. And going to go a little bit out of order here, but another one of our students was unable to make it tonight. So he actually had a last minute thing come up literally during class today. And you can imagine my surprise of hearing, oh, day of, you're unable to make it. But another important thing that we want to emphasize is that engineers do live full lives, fighting stereotypes from like 20 years ago. Engineers have full lives and things happen, and that's okay. So I do want to shout out Preston, who was one of my students in the AM session who worked on an ultrasonic theremin project, who was one of the brand new projects that we had in the yearbook for this year. And he did a lot of work helping us debug through it, through some of that tutorial document. He really hang on. He was very resilient. So shout out to Preston. Sad he's not able to be here with us for today, but that means that our final speaker for us for tonight is going to be Solomon. So, Solomon is one of my PM students, and I would describe him as having another very exceptional quality of an excellent engineer, and that is patience and perseverance. So, Solomon was working on the three-joint robotic arm project and chose to do a modification you guys might have heard previously of trying to make the device wireless. Now, Solomon went through so much iterations on his process, both fighting against the sort of hardware capabilities that he had available to himself to implement the modification, and some of the very particulars of just trying to get the modules to interface with each other, setting a bunch of wireless addresses, getting them to even just power on simultaneously. But he was very patient, asked very politely whenever he had questions, was very self-driven in trying to debug through these issues, and has made a very, very elegant project in the process. And I'm sure he's basically on his way to getting it fully completed. We are so close to it for today. So, Solomon, I'll pass the metaphorical mic to you. Please let everybody know about your ARM project.
Thank you very much, Everest. Hello, my name is Solomon Lloyd. I'm a rising senior attending Friends Seminary, and my project was the three-joint robotic arm. My fellow classmates have already kind of went in depth of what the robotic arm does and its functions, so I won't go through that specifically. However, I will share a quick demo of the base project being finished and its functionalities, if you can see my screen.
Mm-hmm.
As you can see, there are two different joysticks for controlling the parts of the arm, with the left one being for kind of the base movement of the arm, so rotating on the 360 as well as going up and down. And the right joystick is to open and close the claw. It's a little bit jittery, but that's just because of the weight balance from the claw, not exactly the code. And my modification was to make my arm and controller wireless and attach it to a car chassis that I built. However, during this process, I ran into quite the amount of difficulties, with the main one being connecting the two Bluetooths and doing the handshake between them, as that is the most important step that allows for the two signals to be sent between each other. I also had some wiring troubles. However, I was able to resolve that. So you can see here, this is the final piece of all the wiring, and it's a very complex system. If you can see all the pins here, there are a total of 6 different pins and 5 wires, and it's really complex because it requires each one to be plugged into the right point. The voltage needs to be plugged into the voltage or you won't get power. The RX and TX have to be plugged into the opposite pins, or else you won't get the variables and they won't send the signal. And if you don't plug into the ground pin, which I unfortunately ran into as well, the board will overheat and will basically, well, not explode, but pop. So that is a difficulty that I ran into. However, I have been able to get both serials working, not simultaneously, but at different times. So hopefully I will be able to connect them in the near future. And once I do so, I will be able to attach the arm to the car. And another step to that will be to add a separate Bluetooth to the car, to add to the third joystick on the back. So that way I can control the car and the arm separately, because as of right now, if I were to get the Bluetooth up and running, the Bluetooth can only send one signal at a time, which means essentially that I can only either move the car or I can only move the arm. And I feel like that's a little impractical. So in my next future steps, I want to be able to move both at the same time. And I chose Blue Stamp because I've been to engineering programs before, but I really wanted the hands-on experience of building and like being an actual engineer. And these 3 weeks have taught me a lot, as ever said, patience, most definitely, with all the serial errors and the coding errors. And it has also taught me the diligence that is required to build this and like being able to make sure and triple checking your work, even if it's the same thing, there definitely can be a problem. If you change one thing, you have to make sure it didn't change another variable. And so I really appreciated Blue Stamp and Everest for helping me with that. Thank you very much for listening to my presentation. Any questions?
Any questions from the audience for Solomon? Bianca?
So if you were to give like one piece of advice to someone doing your project, what would it be? And would it be something like more technical, or do you think it would be something about just like to make sure to have like patience and like just something like that?
Well, patience is definitely something I would recommend, but honestly, I think the reason I had so much trouble with connecting the serials is because I couldn't plug in both of the Bluetooths into my laptop at the same time, meaning that I had to power the arm on a separate battery, and that kind of makes it the step to connect the serials a lot harder. Because it has unreliable, because you have to switch between the two modules back and forth, and it also has unreliable serial connection because you can't really power them both on at the same time. So if anybody were to do this, I would recommend having a device that allows you to plug in both modules at the same time. Makes it so much easier to connect the serials.
All right, thank you for the question, Bianca. Anybody else have any questions for Solomon?
Yeah, quick one. Is there any reason you're thinking of adding another Bluetooth module, or could you just send a bunch of signals at the same time, and one could be to control the car and one could be to control the arm to the same Arduino?
Because I need to, if I were to control the arm, because I kind of want to be able to control the arm and the car separately. So, like, I want to be able to move the car and control the arm at the same time. But because of the way the Bluetooth module is laid out, only one signal variable can be sent to one Bluetooth module. So, I need two different pairs because it's like if you have your headphones and you plug them into your laptop, you can't really plug your headphones into your laptop and your phone at the same time. So you need two different Bluetooth pair modules, which is why I need another pair to be able to control both.
All
Thank you.
right, thank you. Are there any other questions from the audience? All righty, could I get one big final round of applause for all of our amazing speakers tonight? Thank you guys all so, so much. Again, I want you all to be able to leave this Blue Stamp program with the power, the knowledge to conquer any thought you have, any question you have, any skill you want to learn, any project you want to build, of like crash coursing it over the course of three very intense weeks. So I'm going to go ahead and stop the recording now.